Hello everyone, welcome back to the map of mathematics. In this video we are going to solve the nice exact equation. First we will learn how we can check that this equation is exact differential. So here in the question statement you see some a, b and h, and these a, b and h are constants. So now first we will rearrange this term and we can just cross multiply it by this term, and we will obtain uh, h of x plus by times of dy is equal to minus times of ax plus hy into dx. Okay, now we take the right hand side into the left hand side, and we will get the expression in this form: ax plus hy into dx and plus h of x plus by times of dy is equal to 0. Okay, so here you can just know about that what is exact equation. The standard form of exact differential equation is m of xy dx plus n of xy dy is equal to 0. So this is the standard form of exact equation. When we compare this equation, when we compare these both equations, then we will get the value of m is ax ax plus hy, because here you can see that dx, the coefficient of dx is denoted by m and the coefficient of dy is denoted by n. So here you have, this is dx and the coefficient of dx is m, so this is the value of m, and this is the dy and the coefficient of dy is denoted by n. Okay, so here you have the value of m is ax plus hy and the value of n is hx plus by. And after that the condition of exact differential equation is, we can just verify that is the partial derivative of m with respect to y is equal to partial derivative of n with respect to x. If this expression is hold, then we can say that our given differential equation is exact differential equation. Okay, so now we can first check this expression. Okay, so in order to check this expression, we can take the derivative of m with respect to y, and we can take the partial derivative of n with respect to x. And you know that about partial derivative. So when we take partial derivative of m with respect to y, so all the other terms involved in this expression are considered to be constant and only y be the variable. Okay, so here you have ax, and you can see that we can take derivative with respect to y, so this ax is considered to be constant, and when we take the derivative of constant, so it will becomes 0. And here you have y, the derivative of y is 1, and you will get h because h is constant value, and you have the value of partial m over partial y is h. Okay, now we can find the derivative of n with respect to x, and all the other values other than x are constant. So here you have x, the derivative of x is 1, and here you get h, and here is no terms of x, so we can consider this term as constant, so the derivative of this constant term is 0, and you will get partial n over partial x is equal to h. And now you can see both of the terms, and we can write partial m over partial y is equal to partial n over partial x. Okay, so the condition of exact differential equation is hold, and we can say that our given differential equation is exact differential equation. So after checking the equation is exact or not, we can, if the equation is exact, then we can apply this formula in order to find the solution of the given differential equation. So here we can integrate m with respect to x, and here you put those values of n which are free from y. Okay, so you can just substitute free from x, you can substitute only those values which cannot involve x. You can just substitute the values of n other than x, okay, which is not involves x. So now I can move towards m and n. So here you have m, and we can in m case we can just substitute the value of m completely, and this will becomes integration of uh, ax plus hy into dx, and plus here you can see n. Okay, so this is the value of n, and which is equal to hx plus by, and we can choose those values of n which is not involved x. Okay, so this h of x involve x, so we can just neglect this term and we can choose only this term, because this term cannot involve x, so we can choose by only. So here we can just write b of y and dy is equal to c, and now we integrate this term and we will find our desired solution. So here you know that the integral of ax is will becomes ax square over 2, and integral of hy, here hy is constant, so the integration of constant will becomes hy into x, plus here the integration of the by is by square over 2 is equal to c. Now you can just rearrange the expression, and you can just multiply by 2 on both of the sides, and finally you will get ax square plus 2hxy plus by square is equal to 2c. Okay, so this is our final answer, and thank you so much for watching this video. Please subscribe my channel for more exciting videos.